All right. So as Tori said, I'm here to give you a RESTful perspective on GraphQL. So before I dive in, I wanted to introduce myself a little bit. I am Sara Laupp. I am available on Twitter at Sloppy. It is not pronounced sloppy because I'm not sloppy at all. I am also a software engineer here at Gusto. It is awesome. Please join us. And I am a bassoonist. So a bassoon is an instrument in an orchestra, and this will kind of run through as a theme for the example that I'll be going through in this talk. All right, so we're going to cover a few things. I wanted to go over kind of the basic differences between REST and GraphQL, requests and responses. I'll also introduce you to how GraphQL schemas work, and then we'll build a few queries. But before I get started, I kind of wanted to poll you all to see what your experience is. So raise your hand if you have worked with a REST API. Sweet, that's pretty much everyone. All right, how about GraphQL? All right, and raise your hand if you're brand new to GraphQL. Sweet. That's a lot of you. That's great. So this talk is especially for you all, but hopefully other people will find it interesting too. All right. So the example that I'm going to be working with is this beautiful database. There's a table of musicians, a table of orchestras. Musicians can belong to many orchestras. Orchestras can and should have many musicians. Otherwise, I don't know what that is. That's not an orchestra. And then these two tables are combined with a join table in the middle. And in the REST API world, you'll probably work with this data in a wide variety of ways. So every CRUD operation corresponds to a different HTTP verb. For example, retrieving data calls for a get, creating data calls for a post. And then every request will go to a different endpoint depending on the data that you're working with. But in the GraphQL world, everything is really consistent. So every request is a post. It will all go to the same endpoint. It's usually /GraphQL. And then every request body contains two keys, query and variables. Variables is a little bit more advanced, so I'm not going to go over that today, but we will learn how to form a query string. And that's kind of the heart of doing any GraphQL API request. As for responses, REST and GraphQL have a similar relationship to requests. So REST API responses have a wide variety of HTTP status codes that they can return. And those status codes tell you whether or not the request was successful. And there's also a wide variety of response body formats as well. But again, GraphQL is very consistent. Every single response will have a 200 HTTP status code, and it will have the same format in the body. So it'll be a JSON object with two keys, data, and errors. And then only one of these keys is actually populated in the response, and you can use that to tell whether or not the request was successful. For example, this is a successful request. And if you notice at the bottom here, errors is null, and data is populated. Data will always be an object, and it will contain the result of the query that you sent. This is a unsuccessful request. So again, here at the bottom, you can see that data in this case is null. Errors is populated. It is an array of objects, and each of those objects has the same set of fields. So it'll always have a message. It will have the location in the query string where the error occurred. It will have the path to the object in the schema where the error occurred. And optionally, you can also include extensions. Most people use this for adding some sort of error code to their error responses to make it a little bit easier to handle things on the front end for whatever client is consuming the API. All right, so those are the basics. Let's get into some schemas. So schemas are the heart of GraphQL, and they define a set of typed objects that you can query off of. Taking our example again, this at the top here, this is an example schema that represents the database that I was showing you earlier. So on the left, I have a custom type called musician. This will basically correspond to the musicians table. On the right, I have orchestra. And then note that I don't have an orchestra members type. That is actually taken care of by these two fields here. So one cool thing about GraphQL schemas is that they don't have to correspond directly to the structure of the database underneath. So zooming in a bit on the musician type, I wanted to talk about some of the syntax that you'll see. Anything to the left of these colons, these are called fields. They will be in lower camel case, and each field name corresponds to a resolver method. And that is a function that you define that tells GraphQL how to retrieve the data for that field. On the right-hand side of the colon is the type name. This will be in upper camel case, and it can be either a scalar or another custom type that you have defined. You'll probably notice a lot of exclamation marks. This means that this field is required, and GraphQL will yell at you if it's not populated. And then here's an example of how to define an array of objects. So here, the orchestra's field is an array of orchestra objects, and the orchestra object itself inside the array is required. Cool, so that's our schema, right? That's all we need? Almost. Every single GraphQL schema has two root types. They are query and mutation. And this is how you get and change data in your data store. So going through these real quick, a query is something that retrieves data. And this is a type definition for our example queries. So our query type has two fields that are possible to retrieve. You can get an orchestra or a list of musicians. And then this is how you define arguments for the resolvers. So this says the musician's resolver will take an argument called instrument, and that argument must be a string. And in this case, this argument is not required because there's no bank. Similarly, or contrarily, mutations are the same except they change data. So if you want to get data, use a query. If you want to change data, use a mutation. So here I have the mutation hire musician. Note that the name is not create relationship between musician and orchestra. It is actually pertaining to the domain of what we're trying to do with the data. So one of the cool things about GraphQL is that you have the creativity to name things something other than create and delete. And I find that very freeing. This one also takes some arguments. So again, these arguments will be passed into the resolver. And then again, everything has to have a type associated with it. So here at the end, we're saying that the resolver method is going to return an orchestra object. Cool. So putting it all together, this is what our schema looks like. We got our queries, our mutations, our two beautiful types, and we're ready. We are ready to build some queries, right? Your enthusiasm is killing me. Thanks, David. All right. So building queries is filling in this portion of your GraphQL request. And before we get started, another difference between REST and GraphQL. REST API responses give you every single field that it possibly can. But with GraphQL, you have to ask it for specific fields. So I won't get the ID back unless I say, hey, I want the ID. So seeing that in action, I'm going to go through 3 examples of building queries and mutations. The first one is answering the question, who is in the orchestra, in our beautiful data example thing. So this is equivalent to a REST API request where you are sending a GET request to the endpoint orchestras with the ID and members, right? Cool. So on the left, this is our query string. The first word here is going to be the root level field name. So that's going to correspond to either query or mutation. And actually, query is kind of understood as a default, so we can get rid of that. You'll see a lot of queries that look like this. This just means you're getting data, you're not changing it. And then each set of curly braces, you are selecting the fields on the object kind of above it. So in this case, we're selecting fields off of the query object, the orchestra field to be exact. And then this is how you pass arguments into that field's resolver function. And then our next set of curly braces is querying off of the orchestra object itself. So we're getting the members of the orchestra. And in the bottom right, remember our members is actually an array of musicians. So in the next set of curly braces, we're retrieving full name and instrument from musician objects. Cool. So this is what your response will look like on the right. On the left, I have our example query. And note how parallel the data structure looks between the request and the response. So inside the data object of the response, you see orchestras. And inside orchestras, you see members. And inside members, you see full name and instrument, just like our query string. Cool. I see lots of head nods. This is good. All right, next query. We're answering, who is a bassoonist? I am a bassoonist. This is also not a philosophical question. This is a data question. So this query is equivalent to the REST API request in the bottom right. So it'd be like making a GET request to /musicians and passing in the query parameters instrument equals bassoon, right? So it looks fairly similar. If we go through the same exercise as we did on the last one, the first set of curly braces is selecting musicians from the query object. We are passing in bassoon as a value for the instrument argument, and that will go to the musician's resolver. And then we are selecting within the musician object, we're selecting ID and full name. And so this is what the response will look like. Again, parallel. I had to fit all the musicians on one line, so it's a little bit harder to see, but data contains musicians. Musicians contain ID and full name. Sweet. This is easy, right? All right, let's do something a little bit different. Let's change some data and hire a bassoonist. I don't expect everyone to know what a bassoon looks like. So those are bassoons. And at the end, this is a contrabassoon. We can go into that later. I love playing Contra. All right, so I already defined my hire musician mutation, so let's do it. Instead of query here or nothing, we need the keyword mutation. Cool. Inside the curly braces, we're selecting, there we go. We're selecting the hire musician field off of the mutation type, passing in these arguments, and then from the return type of that resolver, which is orchestra, we're selecting name and members. Members are musicians, so we're selecting full name and instrument off of that. And the way that you know that you're done selecting fields is when you get to a scalar type. So for example, full name and instrument here, those are both strings. So no more custom types, no more nested queries, we're all good. All right, and here's the response. It's all consistent and beautiful, and I love it. Oh, yes, spoiler alert, you just hired me. I should go back. There's my name and my instrument. Sweet. All right. So we've built some queries, and we've talked about schemas, and hopefully we know some of the basic differences between REST and GraphQL. And that's it. Thanks. I think I have lots of time for questions. Yes.
It looked like the arguments that you were passing were strings. They were at least quoted strings. Is that just the way that you defined it, or is an ID type always a string for GraphQL? How does that work?
An ID type, I believe, is always a string in GraphQL. That is the short answer to that question. Yes.
What are your favorite things about working with the GraphQL API as opposed to working with the REST API?
So my favorite things about GraphQL versus REST. I think one of my favorite things is that it's almost self-documenting. So the schema that we generated, or that I showed you in the beginning, with every kind of GraphQL interface that you'll use, like GraphQL Playground or graphical interface, there's a little side tab that shows you the documentation based on the schema that you've defined. So I find that really, really exciting. Nobody likes, well, I like writing documentation, but nobody likes reading it. So having it generated from code is a major plus. I saw another question. Yeah.
Do you use auto type generation between, say, TypeScript and GraphQL? Using something like that?
I'm currently not using that on my team. I think some of the other teams at Gusto have used it, and they might be able to answer any further questions you have about that. Yes.
Piggybacking off of that question, is there anything you don't like about GraphQL? Like, are there negatives that people that aren't familiar with it should know about going in?
Yeah, so the negatives of GraphQL, there are a few that I usually avoid talking about, but one of my biggest, I don't know, question marks about GraphQL is how you should handle errors. So there are two kind of philosophies. One is you always use the top level errors like I showed you in the response. And the other is that when you have a mutation, you return a payload, and that payload is defined in the schema, and that payload includes like an extra errors key. And for me, I like having one place to check errors, so that kind of gnaws at me. Another tricky thing with GraphQL is because you can do so many nested selections here, you can run into n+1 queries if you're not careful with how you're defining the resolvers. Yes?
Is there a shorthand for selecting all fields on, say, a member, or do you have to type them all out?
You have to type them all out. There's no wildcard, unfortunately. That might be a pet peeve if that's something that you want. But if that's something that you want, you probably should use a REST API endpoint. Yeah.
So when you're doing like a more complicated mutation, like you're updating quite a few fields on an individual type, would you just pass the update in as your parameter to the mutation?
The update being?
Like a diff or like the new object, or like if you're doing a put essentially in REST.
Yeah, you can create custom input types.
Yeah.
So that would handle that case. So you could say, okay, my hired musician takes maybe an orchestra ID, and I don't know, maybe I don't have this musician already in the database, so I want to pass in a musician object in the arguments. You can do that.
So like if I were to update a musician and say, well, you know, they got married, so they have a new last name and they play a different instrument now.
Mm-hmm.
Is that how you would approach that?
Yeah, probably. When you're updating a lot of fields, I think, like with most programming languages, having some sort of value object to work with is really helpful. Yes?
What seems to be the preferred authentication mechanism?
That's a heavy question. Yeah, I mean, authentication is a separate beast from GraphQL. You can use most authentication methods, though I will mention most OAuth streams require like a REST API callback. So if you use OAuth, you'll at least have one REST API endpoint and then the rest GraphQL. Yes?
So you mentioned you can leave off the query keyword.
Yes.
And you said that was kind of popular. Do you know why you would do that? Or you would choose, you prefer one method over the other?
I think it's a personal preference. There is something a little bit more advanced where you can name the queries that you're running so that you don't have to, so that you can have multiple queries that you're drawing from and it knows like which query you actually want to execute. And in that case, you still need the keyword query in front. So it might be better to use the query keyword just for consistency. Big shrug.
More questions? All right, another big round of applause.